So for the question number 27, second option is the answer. Next I am going to discuss the question number 28. The acceleration of a block sliding down a rough inclined plane of inclination 53 degrees with horizontal, same as its acceleration down a smooth inclined plane of inclination 37 degrees with horizontal. The coefficient of friction between the block and the rough inclined plane is, so given that sine 53 degrees same as cos 37 degrees, which is 4/5. So in the first case, it slides down the rough inclined plane. The acceleration of the block when it is sliding down the rough inclined plane, fixed rough inclined plane, under the action of its weight mg, normal reaction and friction by the inclined plane. The acceleration is given by g into sine theta minus nu k into cos theta. Here theta is 53 degrees. The acceleration of the block when it slides down the smooth inclined plane is given by the formula. That is, the acceleration of the block when it slides down the smooth inclined plane under the action of its weight mg and normal reaction force by the inclined plane, given by A equal to g sine theta. So in the second case, theta is 37 degrees. So given that magnitude of acceleration is same in both the cases, so you can equate the magnitude of acceleration in the two cases to find the value of coefficient of friction. So magnitude of acceleration in the second case is g sine 37 degrees. That is same as the magnitude of acceleration in the first case, that is equal to g into sine 53 degrees minus nu k into cos 53 degrees. Can cancel the acceleration due to gravity g on both sides. Can substitute sine 37 degrees equal to 3/5, sine 53 degrees equal to 4/5, cos 53 degrees equal to 3/5. This you can simplify it, and you can solve for the coefficient of sliding friction. So the coefficient of sliding friction between the block and the rough inclined plane, you get nu k equal to 1/3. So for question number 28, first option is the answer. Next I am going to discuss the question number 29. See the question number 29. Block of mass 10 kg slides down a fixed inclined plane of inclination 30 degrees to the horizontal with acceleration of 2.9 meter per second square. What is the magnitude of the force to be applied parallel to the inclined surface in order to move it up along the same inclined plane with an acceleration of 2.1 meter per second square? So in the first case, the block is sliding down the inclined plane. So force of kinetic friction on the block by the inclined plane acts up along the inclined plane. So in the first case, you can draw the free body diagram for the block, which is similar to one of the problems I have discussed earlier. I mean part of the question. The weight mg of the block acts vertically downwards. The normal reaction force on the block by the inclined surface acts perpendicular to the inclined surface and directed away from the inclined surface. I choose the direction of the motion of the block parallel to the inclined surface down the incline as x-axis and direction perpendicular to the inclined surface as y-axis. So if the line of action of normal reaction is extended backwards, the smaller angle between the line of action of normal reaction and the weight mg of the block, same as the angle of inclination theta of the inclined plane to the horizontal. So you can resolve the weight mg into rectangular components parallel to x and y axis. The component mg cos theta acts perpendicular to the inclined surface. The component mg sin theta acts down the inclined plane. The block has no motion parallel to y-axis. Y component of resultant force is 0. Therefore, resultant force of block is equal to Fx, means the resultant of force is acting along x-axis. So the component mg sin theta acts in the direction of the motion along positive x-axis. Fk represents magnitude of kinetic friction which acts opposite to the motion. So magnitude of the resultant force of block along the direction of the motion mg sin theta minus Fk. From Newton's second law, that can be written as equal to product of its mass and acceleration. Here given the mass m of the block as equal to 10 kg, g equal 9.8 meter per second square, sin theta equal sin 30 degrees, that is 1 by 2. Let Fk denote the magnitude of kinetic friction of the block. Again on the right side you can write m equal to 10 kg and a equal to 2.9 meter per second square. This you can simplify it. So you get on the left side 49 Newton minus Fk equal to 29 Newton. You can solve for Fk here. So magnitude of kinetic friction on the block by the inclined surface will be equal to 20 Newton. So in the second case, you have to find the magnitude of the force to be applied on the block parallel to the inclined surface so that it can move up along the same inclined plane with an acceleration of magnitude 2.1 meter per second square. Let us draw the free body diagram for the block in the second case. So the block moves up along the inclined surface which makes an angle theta equal to 30 degrees to the horizontal. Let cap left denote the magnitude of force to be applied on the block in the direction of the motion. You can choose the direction of the motion as x-axis up along the inclined plane. The weight mg of the block acts vertically downwards. The normal reaction force of the block by the inclined surface acts perpendicular to the inclined surface and directed away from the inclined surface. You can resolve the weight mg into rectangular components. The component mg cos theta acts perpendicular to the inclined surface. The component mg sin theta acts down the inclined plane. Here the block is moving up along the inclined surface in the second case. So force of kinetic friction of the block by the inclined surface acts down the inclined plane, opposing the motion of the block relative to the inclined plane. But magnitude of kinetic friction of the block in the second case will be same as the magnitude of kinetic friction of the block in the first case. Because the coefficient of friction between the block and the inclined surface is the same in both the cases. The coefficient of friction, I mean the value of the coefficient of friction between the block and the inclined surface is independent of direction of the motion of the block. It is same whether it slides down or moves up. And magnitude of normal reaction of the block is same in both the cases equal to mg cos theta. In the first case, the block is sliding down the inclined plane, so force of kinetic friction of the block acts up along the inclined plane. The second case, it is moving up along the inclined plane. Therefore, for the kinetic friction of the block acts down the inclined plane. So we choose the direction perpendicular to the inclined surface as y-axis. So y component resultant force on the block is 0 because the block has no acceleration parallel to y-axis. So resultant of all the forces acting on the block is equal to Fx, means x component resultant force. Here Kepler represents the magnitude of the force to be applied on the block parallel to the inclined surface by an external agent which acts in the direction of the motion along positive direction of x-axis. The component mg sin theta acts opposite to the direction of the motion, the negative direction of x-axis. Fk represents the magnitude of kinetic friction of the block which also acts opposite to the direction of the motion. So magnitude of the resultant force along x-axis is equal to F minus mg sin theta minus Fk. From Newton's second law, magnitude of the resultant of all the force acting on the block will be equal to product of its mass and acceleration. Second. So therefore, the magnitude of the force to be applied on the block parallel to the inclined surface to move it up along the inclined plane with uniform acceleration A is given by mg sin theta plus Fk plus ma. Here theta equals 30 degrees. The mass of the block is equal to 10 kg. G equal 9.8 meter per second square. Sin theta equals sin 30 degrees, that is 1 by 2. Magnitude of kinetic friction is same in both the cases, which is equal to 20 newtons. The mass of the block is 10 kg. The magnitude of acceleration second case is 2.1 meter per second square. This you have to simplify. Come on, copy down the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and take your own time. I am going to discuss the next problem. So for question number 29, second option is the answer, which I just now discussed. Next I am going to discuss the question number 30. See the question number 30. Next two questions 30 and 31 are based on one of the special cases which I have discussed earlier. In the list of the special case, you can see the special case which I have discussed for motion on the rough inclined plane. This problem comes under the second special case. In the special cases I have discussed for motion on the rough inclined plane. So let us see the question number 30. What is the magnitude of the minimum force to be applied on a block of weight 100 newtons parallel to the inclined surface? Nu s equal 1 by root 3 and uk equal 2 by 3 root 3. A fixed inclined plane of angle of inclination 30 degrees with the horizontal, so that the block just begins to move up along the inclined plane. So here, as I discussed here with explanation, the minimum force to be, the magnitude of the minimum, the block begins to move up along the inclined plane. The magnitude of the force applied on the block parallel to the inclined surface is more than mg into sin theta plus nu s into cos theta. So the minimum magnitude of the force to be applied on the block parallel to the inclined surface so that it just starts moving up along the inclined plane is going to be mg into sin theta plus nu s cos theta. Here the weight mg of the block is given to 100 newtons. Theta is 30 degrees. Nu s equal to 1 by root 3. So you can substitute sin 30 degrees equal to 1 by 2 and cos 30 degrees is equal to root 3 by 2. So you get answer as 100 Newton. So for question number 30, first option is answer. The next question number 31 is also based on this same discussion which are done for 30. The previous question, what will be the acceleration up along the incline? If the same force is maintained even after motion begins. This problem also comes from the same special case which I have discussed. Earlier I told you that if a block is placed on the rough inclined plane and if a force is applied on the block parallel to the inclined surface, which is just sufficient to start the block moving up along the inclined plane. And if the same force is maintained even after the motion begins, then magnitude of the acceleration of the block is given by nu s minus nu k into g cos theta. Here nu s equal to 1 by root 3. Nu k is given to be 2 by 3 root 3. G is given as 10 meter per second square. Theta equal to 30 degrees. So this, if you simplify, get 1 by 3 root 3 to 10 meter per second square. Cos 30 degrees is root 3 by 2. So you get magnitude of the acceleration as 5 by 3 meter per second square. So in case you are given this problem in any one of the entrance examinations, I mean similar problem, you can directly use this conclusion which are derived in one of special cases. But in case you are given similar problem in the board examination, you cannot use this conclusion directly. So in the board examination, you are supposed to derive this result first, and then you can substitute the numerical values. For question number 31, third option is answer. So I have finished the discussion of all these, solutions for all the questions, 31 questions in the assignment and fraction. So here I would like to give some advice for some of the students who may feel the problems difficult. So the number of, you can check up the answers after working all the problems. See, some of the students may not be able to solve most of the problems in the first effort. That means when they read one by one, questions one by one from 1 to 31, out of 31 questions, see the number of problems which a student can solve, that will be definitely different for different students. One student out of 31 questions may be able to work out 28 problems, and another student may be able to work out only 20 questions. Another student may be able to do only 10 questions. There may be some students who may be able to do only 2 or 3 questions or 5 questions. In case you feel that you are very weak in physics and you are unable to solve any problems on your own, then you try to do this way. You follow this advice carefully. Suppose if you feel that you are very weak in physics and you are unable to solve even 1/4 of the questions in each assignment, when you try for the questions for the first time, you can do like this. Okay, doesn't matter. See, there is a chance for everybody to improve, but one has to put an effort to improve. Nobody can improve without putting an effort to improve. So in case you are very weak in solving the problems, I mean if you are suppose able to solve only 2 or 3 questions or 4 questions out of 31 questions when you try for the first time, or less than 10 questions, then you can do like this. You go through the solutions I am discussing. You go through all the classes where I have discussed the solutions of all the questions first, all the 31 questions. So going through the solutions, then you can do like this. The next day, we again go back to the class where we have shown the questions. That means you go back to the beginning of the assignment in friction. Then again you start afresh. That means assume that you are again to start the assignment in friction freshly. Again go through all the questions 1 to 31, one after another. That means again go to the previous class where I have shown you only the questions without solutions and answers. So go through all the 31 questions one by one. Then you try to work out those questions yourself, without looking into the solutions you have copied or answers you have copied. So then, that means once you have already listened to the solutions of all the questions, next day you try to solve these questions yourself again without looking into the solutions and without looking into the answers, so that you can check up whether you are able to solve a problem yourself after listening to the discussion or explanation I have given. So those students who are unable to solve any questions when they try these questions for the first time, after listening to the solutions for all questions, the next day they can make a fresh start, again work out all the questions in the assignment 1 to 31 without looking into solutions and answers. This time you will be able to solve more number of questions. Probably you may be able to solve most of the questions. So what is required is, by the time you are going to write the entrance examination, in case you are given any one of these questions or problems, or I mean either same question or same model questions, you should be able to solve it in the examination. Okay. So next class, I am going to show you the questions in continuation to the 31, after 31. The assignment friction is not completed. Still there will be more questions in friction. So next class I am going to show you the questions numbering from 32 onwards, 32 to 60. First I will be showing the questions one after another. You can see the questions, try them yourself. So for each question I may give little time, because some of the students may be able to do very fast, and if I give more time, more pause for each question, they may feel that the time I am wasting their time. So therefore, when I show you the questions for the first time, I may give you little time, the time which is needed for the students who work very fast. But in case you need more time to answer the questions, you can take a pause for each question. Before I read the next question, you can take a pause after the first question and try to take your own time. Then you can remove the pause and next you go through the next question like that. You follow the same procedure even for next questions also. Again, go through all the questions, try them yourself first. Later I will be showing you the answers for all the questions, so you can check up your answers. Then I will be discussing the solutions of all the questions. Then you can go through the solutions of those questions wherever you have gone wrong or you need explanation. In case you are unable to do well, even for next set of questions, you can again first go through all the solutions of all the questions. then the next day you again make a fresh start, again start going to the question starting from 32 to 6, then work out 32 to 60 like that. So then definitely you will improve.